Hello, AP Stats. This is Lesson 5.2a, which is probability rules, or rules about probability, but I prefer to call it probability rules. Yeah, I know that was a corny joke. That's okay. And we're going to do a bunch of vocab, and also we're getting more into the math behind theoretical probability and how do you calculate it. So, vocab first, and probably some more later. So, vocab for probability. Some of this you may have heard in other classes. Sample space is a list or a set of all possible outcomes. And we'll start with a simple example. If I flip a coin, I have heads or tails. Let's make it more complicated because it's more interesting. If I flip two coins, ooh, getting big, then my sample space is I could get heads, heads, I could get heads, tails, I could get tails, heads, or it could get tails, tails. There's four things in the sample space. And we might decide to group these ones together and say I could get two heads, or I could get one head, or I could get two tails. If I do that, then they're no longer equally likely, and that would be important. In fact, that would be part of my next vocab thing, which is the probability model, or sometimes called a distribution. So the probability model is just the sample space with probabilities added onto it. It's the sample space plus the probability of each thing in the sample space. That's a B, not a P. So, for instance, on this particular sample space that I just did, I'm going to go ahead and group those and say I want to know the probability of 0 heads, the probability of 1 head, well, I wouldn't need the apostrophe S, would I? And a probability of 2 heads. And as you can see from this sample space with 4 equally likely things, there's one way out of 4 to get 0 heads. That's 2 tails. I pointed at the wrong one. 1/4 or 25%. There's 2 different ways out of the 4 to get 1 head. 2/4, which is 1/2, which is 50%. And then 2 heads, there's one way to get that out of the 4. And you could also graph that. So you could make a little graph of 0, 1, 2, and the probability. I only need to go up to 50% because that's the most likely thing that would happen. So 0 heads is 25%, and 1 head is 50%, and 2 heads is 25%. Little histogram of that. And notice that these have to add up to 100%, which is a sign that you have a valid probability distribution. So they always add up to 100% if you did it right. So let's do another example because this one's pretty simple, only 4 possible outcomes. Let's do something with more outcomes. Let's say instead of flipping 2 coins, we're going to roll 2 dice and add them up, or find the sum. So the sample space for this has a lot of stuff in it, but I'm going to write it all out because it's something that might help you later on with certain homework problems. And I'm going to put the first die, I'm going to make this a table instead. The first die could be 1, 2, 3, 4, 5, or 6. The second die could be 1, 2, 3, 4, 5, or 6. And I'm going to fill this in with the sums, which actually, if you think about patterns, you can go a lot faster. 1 plus 1 is 2. 2 plus 1 is 3, but you could also get 3 by doing 1 plus 2 instead of 2 plus 1, right? And then there's a diagonal row of 4s. 4 could come from 3 plus 1 or 2 plus 2 or 1 plus 3. And then there's some 5s. And then there's some 6s. So I prefer to write it this way so that I don't have to think so much by going sideways. The biggest number you could get is 7. 6 plus 1 is 7. These ones are all 7s. And then it starts going back down again because, no, it doesn't. It goes down as far as the number of possibilities, but the numbers keep going up. 6 plus 2 is 8, but there's only 5 ways to get an 8. And my lines are not very straight. 9, 10, 11. If I wanted it to be perfect, I would have put that on graph paper, but that's okay. But this is a list of all possible outcomes, and that's called the sample space. If I want to add the probabilities onto it, then probably I would want to join the ones that match. So I would take these 2 3s and put them in the same group and find the probability of that. So here's the probability distribution. It is, instead of writing it like this, I'm going to make a table out of it. So I'm going to say the sum and the probability of that sum and make a table. I'm not going to make a graph. So the sums could go anywhere from 2 to 12. Let's make that list. And then all of these are 6 times 6 is 36. They're all going to be out of 36. I'm not going to reduce them because it's so much easier to see the pattern if you don't reduce. So 2, there's one way out of 36 to get a 2. There's 2 ways out of 36 to get a 3, and you can reduce that if you want, but I would just leave it. 4, there's 3 ways out of 36. And these keep going up until they get to the 7 that has 6 possible ways, and then it goes, this is what I meant by going back down again. So 3, 4, I'll put the 36s in a minute, 5 ways, 6 ways, and then back down to 5, 4, 3, 2, 1. And all of these are out of 36. So there's a probability distribution that's a little more complicated. If you've played games with dice, you probably already knew that 7 is the most likely thing that could happen. 6 chances out of 36. And then least likely would be a 2 or a 12. And again, if you added these all up, they ought to come out to 36 out of 36, which is 1, because that means I counted them all. So basically, there's your probability distribution of 2 die rolls. All right, some more vocab. I'm going to put a line like this because I'd rather not waste this space right here. So we talked about events already in 5.1. An event is any collection of outcomes. And so depending on what you're interested in the situation, that would determine your event. For instance, I might be interested in the probability of getting a sum of 5, and that would be my event. And theoretical probability of a sum of 5 is 4 out of 36, which if you want to reduce it, it would be 1/9. Or you could change it to a percent. You could combine some of these if you wanted to. So you could do something like the probability of a sum of 3 or less. And that would be combining the 3s and the 2s into one thing. And there's 3 ways that could happen. 1 plus 2, 2 plus 1, or 1 plus 1. There's 3 ways out of 36 that could happen. Or you could just add these together, which was coming up. One of our rules is that you can sometimes add probabilities. That reduces to 1/12. So your event could be a single outcome like a sum of 5, or it could be more than one outcome like a 3 or less. Technically, the sum of 5 has 4 outcomes that got combined into that category. So you can group them however you need to for the problem. More vocab, there's a thing called mutually exclusive, which maybe you've heard of before. Mutually exclusive literally means that each one excludes the other. If this one happens, then the other one doesn't happen, which means they can't both happen at once. I like the shorter term for this, which is disjoint, because I get tired of writing out the word mutually exclusive. But what happens generally with my students is I'll say disjoint and somebody will raise their hand and say, what does disjoint mean again? And I'll say it means mutually exclusive, because most people have heard that one in other classes. So disjoint means they can't both happen at once. For example, you cannot get a 5, sum of 5, and doubles at the same time. 5s can come from 1 plus 4, 2 plus 3, but you can't get two numbers that are the same adding up to 5. It just is impossible. So disjoint, the official definition of disjoint, is that the probability of A and B, where those are your two events, is 0. If the probability is 0, then they are mutually exclusive or disjoint. By the way, and in stats books has another symbol that I should show you. It looks like an upside down U, or it kind of looks like an A without the crossbar, or it kind of looks like an N. That helps me remember that it means and. So there's the official symbol for that. So that's the first official formula in this chapter. What do you know? And then one more vocab word and then some more formulas. Lots of formulas in this chapter. Complement. That's an E, not an I. Complement means, oh, you look so nice today. Complement, well, in geometry, it means adding up to 90, which is not what it means in statistics. In statistics and probability, it means adding up to 100%. Or in other words, all the other outcomes that are not in the event are called the complement. The official symbol for that is A to the C power. It looks like an exponent, but it's really just a superscript, which means the complement of event A. Or it means not A, basically. So if I do 3 or less, the complement of 3 or less is more than 3. Because we're taking 3 or less, which is here, and everything else is the complement of that. This could be written as x is less than or equal to 3, and this could be written as x is greater than 3, if x represents the sum. And complements always add up to 100%, which is one of the basic rules that we're about to write in this next piece. Basic probability rules. I'm hoping there's not a whole lot of huge surprises in this lesson. It feels like this is stuff that maybe other classes have covered, but if they haven't, you need to know it for this class. So, basic probability rules. All probabilities we said the other day are between 0 and 1 for any event A. I'm going to make a box out of this because it's important. And that could also be written as 0% and 100%. I hope you're good at switching back and forth between numbers and percents. We're going to do a lot of that in this class. So if you need help with that, let me know. S is sometimes used as a symbol for a sample space. The sample space includes all possible events or all possible outcomes for a particular situation, which means that the probability of S means the probability of a sum between 2 and 12. Probability of any of these sums is 1 or 100%. Or in other words, the probabilities of the whole probability distribution or the whole sample space always add up to 1 or 100%. And that is if the sample space is done right, which means it's complete, not leaving anything out, and is disjoint, which means no overlaps. So I would not want to put a sum of 3 and a sum of 3 or less as two different lines on this table. I'd want to leave them separate. Complete means nothing left out. Disjoint means can't overlap or happen at once. And then the complement rule, which is kind of common sense, I guess. The probability of the complement of A is always 1 minus the probability of A. So if the probability of 3 or less is 1/12, then the probability of more than 3 would have to be 11/12 because 1 minus 1/12. And so that's officially the definition of complement. And then the addition rule I mentioned a minute ago, but I didn't write it down yet. Addition rule for disjoint events. We are going to later talk about events that are not disjoint, but not yet. The addition rule says if you have two events that are disjoint, that is, they can't overlap, and I want the probability of A or B, notice that's not an and, it's an or, then I can just add them together if they're not overlapping. If A and B are disjoint, I can add them together. And I did that a minute ago when I did the probability of 3 or less. I did the probability of 2 plus the probability of 3, and I added them together to get the 3 or less, and that's where I got the 3 out of 36. So if they're disjoint, you can add them together. Just like and up here, I should probably put a box around this one too because it's important. Just like and has a special symbol, or also has a special symbol that looks like a right side up U. It also means union or A and B combined into one thing. And that's the same rule exactly. I want you to get familiar with those symbols because on the AP test, they use those symbols instead of the words. And you need to be able to do that. So I'm going to do the end of this box and then one more example and then we're done. So here's an example.